mc² is one of the most famous formulas in physics. But what does it mean? How does it apply to real life? And why is it not always positive in every situation? Let's explore all this in today's video. If you want to know about what is origami, see episode 16, link in the description. We are familiar with different forms of energy, such as sound energy, light energy, and heat energy. Similarly, another form of energy is the mass of an object. In 1905, Albert Einstein introduced the concept of mass-energy equivalence through his groundbreaking formula, E=mc². He published a research paper that explained how mass is essentially another form of energy. If we multiply the mass of an object by the square of the speed of light, it gives us the amount of energy contained in that mass. For instance, the energy in just 1 gram of matter is enough to boil 3,012,050,000 kilograms of water into steam. To convert mass into energy, let's take the example of two hydrogen atoms. Through nuclear fusion, these two atoms combine to form a helium atom. However, the mass of the helium atom is slightly less than the combined mass of the hydrogen atoms. This lost mass is converted into heat energy. This principle is applied in hydrogen bombs. The heat energy generated by this process is so immense that it can destroy an entire city in moments. Now, let's discuss how energy can be converted into mass. When you apply energy to an object, it starts gaining speed. If you apply even more energy, it will approach the speed of light. The extra energy beyond this point doesn't disappear, it is converted into mass, causing the object's mass to approach infinity. But why isn't E=mc² always positive? When an object moves relative to your frame of reference, the formula changes to E=gmc², where gamma equals 1 divided by the square root of 1 minus v squared over c squared. If the object is stationary relative to you, v equals 0, and the formula simplifies back to E=mc². So E=mc² is positive only for stationary objects. When an object moves at the speed of light like a photon, the formula changes again to E² = p² c² plus m² c to the 4th power. Here, if momentum p equals 0, the formula simplifies back to E=mc². In conclusion, E=mc² applies to stationary objects but transforms for moving objects. This equation reveals the incredible connection between mass and energy, reshaping our understanding of the universe. If you enjoyed this explanation, subscribe to the Science Sphere for more videos on science and innovation.